Hi everyone. For today's lecture, we will continue discussing the case study for risk pooling, which we have discussed half of this. We discussed the demand sheet for this case study in our last in-person lecture. So before I start, I would like to recall the formula that we will use to complete this case study. So the total inventory for the current and the centralized strategies can be estimated by comparing the corresponding average inventories. So average inventories is one of the key factors that we will consider. So we need to compute the average inventory, I bar, and it can be calculated by Q over 2 plus safety stock, where Q is the order quantity here, and can be calculated by this formula, the square root of 2AD over H, where A refers to the order cost per order, and D refers to the average demand, and H refers to the holding cost per unit per year. And then by using the min-max inventory policy, I bar can be calculated by this one. And the first term Q over 2 refers to the average replenishment cycle. And the second one, K times SD times square root of L, lead time, refers to the safety stock. So we calculated the average inventory in this way because we want to consider both the average replenishment cycle and the buffer from the demand uncertainty. So we need to add the safety stock here. All right. And another quantity that we need to calculate is the reorder point. We denote it as R. R can be calculated by safety stock plus DDLT, which refers to the demand during lead time. All right. Then let's move to the calculation part. Firstly, we focus on the demand sheet. So for the demand, we need to calculate the summary for both product V and product W. And then for each product, we need to calculate the average demand, the standard deviation of the demand, and then the coefficient of variability. All right. I believe all of you have already know how to calculate these three. I will just briefly go through this part. So for the average, we need to calculate average for each location among all the weeks, among all the 13 weeks. Then we can by using the formula here, we can get the average inventory for the 13 weeks, right? And then for the standard deviation, we calculate the standard deviation for each location over the 13 weeks, right? Then we can get the standard deviation of the demand for each location and for each product. And then for the coefficient of variability, we use standard deviation of demand divided by the average demand, right? And then similarly to the product V, we will do the same calculation for product W to get the average demand, standard deviation demand, and the coefficient of variability for each three locations. And then after that, finally, we would also like to calculate the total demand for these three locations, which means if we have a centralized manufacturer or a distribution center, then what will the average demand, the standard deviation of the demand, and the CV look like, right? So after that, we firstly need to calculate the summation for each week for all the locations. For example, for this part, we need to calculate the summation of 50, 30, and 25. Similarly, for the second week, we need to calculate the summation of 40, 15, and 30. And then similarly to the following weeks, we need firstly calculate the summation of all three locations for each of the 13 weeks. Okay, and then same as the previous one, we need to calculate the average and the standard deviation of demand for the total for the total one, which we can regard it as a centralized location. And then CV can be calculated by using the standard deviation of demand for the total row and divided by the average demand for the total row. And this is how to calculate the summary for the product V. And same as V, we can calculate the total row for product W and then get the average standard deviation of demand for it. And then finally get the CV coefficient of variability for this row. All right. Then we will move to the inventory part. Let me make it larger. All right. Then here I would like to mention that for this case study, we have different holding cost, which means the holding costs for the two different products are not the same. And then we would like to achieve a filling rate equals to 0.99, which means our Z score, Z value, and it denoted as K here, should be equal to 2.33. All right. Then for this table, I will firstly go through about how to calculate the quantities in this table first, and then move to this table. Okay. For the first one, which is DDLT, which refers to demand during lead time. And then the demand during lead time can be calculated by using average demand times lead time. And the lead time can be calculated as the summation of supply time and delivery time. So it's the summation of these two numbers. Okay, because our delivery time equals to 0, so for this case, we have lead time equals to 2 weeks. All right. So this is why we can calculate the DDLT by using the formula here. All right. Then next we move to safety stock. Safety stock, I believe all of you are very familiar with it. We can calculate the safety stock by using the value for Z here times square root of lead time. And lead time we have already calculated by summation of supply and delivery time and times the standard deviation of the demand. So that's the reason why we can use the formula here to calculate our safety stock. All right. Then we move to Q, which is the order quantity. Maybe some of you are not very familiar with this quantity, but I would say it's very important quantity that we would like to quantify, especially when we have the information about the order cost, average inventory, and the holding cost. Okay, and then by using the formula here, we can calculate our optimal order quantity by square root of 2 times order cost per order, which is given here. Ordering cost and the average demand, which has been calculated in this demand sheet right here. And then divided by H, which is the holding cost per unit per year, which is given here. All right. Then by using these three quantity, we can calculate our optimal order quantity by using this formula. Okay. And next is the quantity R, the reorder point, which can be calculated by the formula here, which is the safety stock plus DDLT. And because we have already calculated DDLT and safety stock, then to calculate R, the only thing we need to do is to summarize the value here and here. All right. And finally, we have all the information we need to calculate the average inventory. And the average inventory can be calculated as Q over 2 plus safety stock, as we mentioned here. Therefore, for this part, we use Q, we already calculated over 2 plus safety stock here. All right. Then we do the same thing to different products and for different locations. All right. After that, we also want to do the centralized, we want to do the same calculation for the centralized manufacturing center. So we calculated DDLT and SS and Q and R by the same way, but using the information for total, right? And I want to point out that for the central center, the central distribution center, they are also designed for different type of products. So for Q here, for product V and for product W, we are using different holding cost and a different ordering cost, right? Okay. Then that's all for this table here. And then after completing this table, we can get summarize the table by using the quantities that we have already calculated here. So here, for this table, we can see that the goal of this table is to compare decentralized and centralized warehouse for the inventory, right, and the holding cost. Then for decentralized, for the products, the units of the products, we will calculate the summation of average inventory for these products in 3 locations, right? In location Houston, in Dallas, and San Antonio. Then, therefore, we need to use the formula here, summation of column G, 9 plus G11 plus G13. All right. And then on the other hand, for centralized, we only have one location, which is centralized, right? So the centralized summation of product V should be exactly the same as the average inventory here for the central warehouse. All right. And then because we want to we want to compare the two different inventories, then we want to calculate the percentage of change. To calculate that, we need to use the centralized one minus decentralized one divided by decentralized one. Then we can get the percentage changed. All right. And then for similarly to product V, we do the same thing for product W. As shown here, for product W, we will calculate the summation for the product W in 3 locations. And then for centralized inventory, it should be exactly the same as the one that we calculated here. For the central warehouse product W, the average inventory. All right, and the same as the previous one, we calculate the percentage of change by using centralized inventory minus decentralized inventory divided by decentralized inventory. All right. Lastly, we need to calculate the total changed for 2 products, right? So for two products, we firstly for decentralized, we need to calculate the average inventory for 2 products, and for all 3 locations, right? We can directly summarize these 2, or you can also calculate the summation from column G9 to G14, right? You will get the same answer here. And then for the centralized, similarly, we can calculate the summation of these 2, or we can calculate summation of these 2, the G15 and G16. And then for change, the percentage of change, same as the previous 2, we calculate we use the centralized inventory minus decentralized inventory divided by decentralized inventory. Because we round up the number here, so it's approximately equal to minus 0.4. So you are encouraged to calculate it by your own. If not, round up, it should be not exactly the same as this one, okay? And for the holding cost, because the holding rate for product V and W are not the same, so we need to use the total number of product V times the product V holding cost rate, and plus the total number of product W and times the holding rate for product W here. So the formula that we should use to calculate the holding cost is here. All right, this is for the centralized. This is for the decentralized. And similarly for the centralized, we calculated in the same way, use the column L and the holding rate for the 2 products. All right. And finally, we also want to compare how the holding cost change. So we also want to calculate the percentage change for holding cost. Then we use the centralized holding cost minus the decentralized holding cost divided by the decentralized holding cost. Then we can get the percentage changed here. I want to point out here, because our holding cost for the 2 products are not exactly the same, so the percentage of changes for holding cost and and the percentage of changes for inventories are not exactly the same. So although after round up, they are approximately equal to minus 0.4, but when you calculate it by your own, you will find that the number here are not the same as the number here. All right, you are encouraged to check by yourself. All right, then that's all for calculation part. And then to better understand why we need to build such a centralized warehouse, I have the following 4 questions to you, and I would like to discuss these 4 questions together with you. So for the first question is that, can you give an example for the effect of risk pooling? The example means that which week for which product for the effect of risk pooling. So you have some time to think about this question. So the effect of risk pooling means that building a centralized warehouse is better compared with without a centralized warehouse, right? In terms of the demand variability. Then for this question, if we want to answer this question, we want to give an example that the centralized variability, the demand variability is indeed smaller compared to the localized ones, right? Then we can move to the demand part. I give an example, which is product W from week 11 to 12. We can see that for the centralized, if we have a centralized warehouse, then the demand does not change from week 11 to 12, right? Which means the variability equal to 0. However, if we focus on the localized warehouse, we can see that there are quite large changes in all 3 locations. For Houston, the demand decreased from 15 to 5. And then Dallas, the demand increased, right, from 0 to 5, and the same as San Antonio, the demand also increased from 0 to 5. So which means if we do not have this kind of centralized warehouse, then it's quite difficult for us to handle the changes. Some locations have has increased and some locations decreased. And if we have this kind of centralized location, which means then the demands does not change from week 11 to 12. Then from this period, this period can be regarded as an example that can perfectly show the effect of risk pooling. Okay. All right, that's an answer for question 1. And then for question 2, on the opposite direction, can you give an example which week for which product when the effect of risk pooling is diminished? Which means if we have a centralized warehouse, it cannot help to control the demand variability. I also give an example here, which is product V for weeks 7 to 8. So from here, we can see that the centralized warehouse, the demand change from 85 to 70, right? So the change equals to 15. And then for the localized one, the summation of demand change also equal to 15. So in this case, in Houston, the demand decreased from 40 to 35, and Dallas also decreased from 30 to 20, also decreased and decreased from 30 to 20, and San Antonio keep the same. In this case, because the localized demand, they change in the same direction. In this example, both Houston and Dallas has a decrease, the demand is lower from week 8 compared to week 7, right? And then in this case, the risk pooling is not effect. All right, so this is one example that the risk pooling is not effect. And you may have other examples. If your example can also show the risk pooling this diminished or the risk pooling is effective, then they are also work. Okay, and you are also encouraged to share your example with me. And the third question is that the EOQ model, excuse me, so the EOQ model is designed to balance which cost and which cost, and why? Before answering this question, let's go back to the formula and to revisit the formula. So here, so Q can be calculated by square root of 2 times A times D over H, right? And A means the order cost per order, and H means the holding cost, a holding rate, the per holding cost per unit per year. All right, then by observing this formula, we can know that if the order cost is increasing, then the order quantity Q will increase together with A, with the order cost, right? And on the other hand, if the holding cost is increased, H is increased, then together with H, our order quantity Q will decrease, right? Actually, the formula to calculate Q is to try to minimize the summation of ordering cost and annual holding cost. All right, so the answer to this question is that the EOQ model is to try to minimize the sum of ordering cost and holding cost, so to balance the order cost and holding cost. The reason is that ordering too frequently will increase the order cost, right? Because we need the total number of orders we need are increased. Well, ordering too infrequently leads to higher holding costs, which means we ordered a lot per order, and then we need to store inventory. We need to arrange the inventory to all the items that we have already ordered. Does it make sense? So this is the reason that why EOQ model is to try to balance ordering cost and holding cost here. All right. Then finally, the last question is, why does risk pooling work better when there is high variability? So the reason is that the higher the coefficient of variation, the greater the benefit obtained from centralized systems. This is because that the average inventory depends on the order quantity and the safety stock. Most of the reduction in inventory comes from the safety stocks. Therefore, the larger the CV, the coefficient of variation, the larger the reduction in inventory. Then risk pooling is potentially work better when there is with high variability. All right. Then that's all for the case study for risk pooling. please make sure to know how to calculate these quantities here and the quantities here. All right, because we may have some very similar question to this one in the coming exam too. All right, that's all for this lecture.